Hi guys, we're from Virgin Media O2. We're a UK organisation and we specialise, well we don't specialise, we are one of the major players in telco and broadband services across the UK. First thing I would like to say, thank you for coming. There's lots of presentations going on at the moment and you've made the right choice. Cool.
Yeah, I'd like to think we all look different enough. We don't need to do the introductions, but we probably do need to introduce ourselves as a company. So we are two parts to a company. Virgin Media are a broadband, television, and home phone services supplier. O2 is the largest mobile network operator in the UK, and about 3 years ago, they merged together in what is the largest UK telco merger. And as part of that, both services have been moving from on-prem service to the cloud. So an awful lot going on in our area.
So as the next step, what I want to do is I want to just sort of explain our problem at the moment. So can everyone who's got a mobile phone put their hands up? Yeah, that's everybody. And then anyone who's got the iPhone 16 that's just been released, put your hand up. And there we have one. Can I ask why you got the iPhone 16? Time. Yeah, cool. And then yourself, sir, can I ask why you didn't get an iPhone 16?
Never had an iPhone.
Never had an iPhone, brilliant. Or the Samsung A22 now. Do you have that?
21.
Yeah, okay.
Waiting for the refresh.
So basically what's happening in this market is 5 years ago, that would have been a totally different story. Yep. They would have been 30% of the room that puts out, I've got the latest iPhone, I've got the latest Samsung. People are not going with the products anymore. It's happening in broadband when we keep increasing the broadband speed, 1 gig, 2 gig, it doesn't matter. And even with 5G and 4G on telecoms, it doesn't matter. 4G is good enough for virtually all our usage on mobile phones. Yes, we have 5G, but actually, what is the real reason why 5G is there? 5G is there because basically, it is there for network systems. It's there for driverless cars. It's totally different, low latency interconnection in a network. You don't need that with your phone. Yeah. And once technology, no matter which way we look at it, meets the basic desires of the consumer stops buying the next product, okay? Until there is a more advanced, proper reason, a proper benefit to the customer to move on. And therefore, we end up in a situation where people are not buying new contracts with us. People are not going the highest broadband service with us. And we're having to move from a product company to a customer company. Every year for the last 20 years, we've just waited for the release of the iPhone. We've waited for the release of the Samsung. We've increased our internet speeds, and people have just renewed. Now, customers want something different.
So there's a couple of case studies I want to talk to on this mark. If we start with Nokia, anyone here who is my age or older will remember the Nokia 3210. It was very basic, but it was the phone to have. Nokia were the big player, and then they fell behind. And it's best summed up by the quote of a departing CEO who said, "We didn't do anything wrong, but somehow we lost." And what this is referring to is the fact that they didn't see the jump to smartphones until it was too late. And then once they were on the smartphones, their app store was very unintuitive. Developers didn't want to work with it. And the app store is very important for customers to be able to personalize their phone experience. So they ended up losing the fight. On the other side of the case studies, we have Nintendo. Anyone wants to shout out? Can anyone tell me when Nintendo was formed as a company? No one wants to venture.
There's a DBT guy here. You can have a guess.
Well, he's got it now.
Okay.
Yeah. They were formed in 1889, and they originally made playing cards. And they realized the limitations of their business. They saw that customers wanted more. So they ventured into toys. They ventured into love hotels, which we don't need to go into at the moment. And then they went into what we know them for, which is their electronic toys and games.
Cool. So this is where we came into Virgin Media O2. 2.5 years ago, Ollie, myself, Aaron, we were brought in as people who've been working in e-commerce up to then and saying, can you help us? We need to go digital. Well, that didn't mean anything to me. But basically, the crux of the matter is they wanted to stop being a product-led organization, become a customer organization, and the only way they saw of doing it is by going to the e-commerce part of the UK, dragging a load of people off and saying, help us set up. So we joined, and I remember my first meeting where we were sitting there, and they said, right, this is the plan, Gordon. We're going to take our old stack, on-prem stack, and we're going to move it across to GCP, and we're going to run it like that. And I just went, well, that would be the biggest mistake you'll ever make, and you'll die. And they turned around to me and said, what's your plan? And I said, well, my plan is to rebuild everything and get rid of 20 years of technical debt and just start again. They all looked at me as if I was mad, and they said, well, how do you intend to do it? And I said, I just need, and we started off with a team of 4. I did ask for a bit more than that. But we started off with, including myself, a team of 4, and we were up against approximately 100 to 200 different contractors doing the lift and shift. So the company basically split us. One they called digital or change. The other was the traditional company, and we went head to head. What I said to them at the time was, the other team are going to lose simply because, and I'll try and get this story in now, is the Gordian knot. Now, I don't know if any of you guys know what the Gordian knot is, but when Alexander the Great was conquering Asia Minor, he got to one state in Asia Minor where they said, you can own all the land, provided you untie the knot. So Alexander the Great, he had a massive army. He could have sat there with his army untying the knot. But Alexander the Great wasn't like that. He just took out his sword and he cut it in half, thus untying the knot and getting all the land. And basically what we ended up with is 200-odd engineers untying 20 years of technical debt versus us, who just said, right, greenfield site, we're going to get on with it. And a year later, we'd finished, they were still untying 20 years of technical debt in their system. So how did we go about it? So what we do as a team is we see real tight synergies with manufacturing. We're taking raw data and we're building products. We also, as a team, have stepped away from, shall we say, Kimball or star schemas, and we look at our system as product, modular builds leading to products and models. Models servicing analytics, products servicing AI, ML, MLOps, all those guys. For us, that's really important. We see the synergies with Toyota, and we actually, instead of making up our own philosophies, we just copy the Toyota way. And basically, where we start is stability. We really want to build a stable product that we want to push through. That includes continuous improvement and accountability for each member of the team. Then we standardize everything we do. We do our deduping. We do every step of a process in the same way. Each DAG is doing the same thing on every product until a certain point where it deviates into its own unique code. Internal quality. We really focus on this because we believe fundamentally, from the Toyota way, to stop at the point of failure. There's no point processing data if the failures occurred here and you're still processing data here. You stop at that point of failure. It's much quicker to pick up and work out what's gone wrong. And in that, we've got over 600 quality control checks within our daily run. The third thing is motivated people. I'll skip back a slide. If we had decided to unpick our data of 20 years of debt, we would have just had BAU specialists in there. By bringing in new people, that encourages them to innovate, to build new stuff, to really think about stuff. And that's actually what our talk is about today. And that will enable us to go customer first, shortest lead times, best quality and low cost on GCP. We have one more thing that we want to talk about today, and that is what we call just-in-time. Now, just-in-time doesn't mean real-time data. Just-in-time means that product is servicing at a constant latency. It may be under 1 minute, it may be daily, it may be once a month. But that's the latency of the product, and that's what we refer to just-in-time. And what we want to talk through today is about how we do that with continuous flow, leveling out our production, and using a pull system to do that. There's the old story of Jeff Bezos at Amazon, where he whenever he had a meeting, or any of his executive had a meeting, they had to have an empty chair at every meeting. And that chair was called the customer chair. And it's because Jeff always felt that the company were making decisions without the customer. And as we go customer first, we really have to consider that. What does our customer mean, and who is our customer? We've got stakeholders, and we've got the end user customer. So we've got two sets of customers always to think about. But that really drives our focus into meeting the quality and the stabilized products that we develop. And as we build more products in lower latency, the demand just goes up and up and up. So at the moment, we're at the start of our journey. We've released about 6 low latency products across the board. We are now seeing the demand from our stakeholders going up, and also from other parts of the company directly in contact with the customer. And this is the story that we want to talk to you about today, is one of these that's slightly different for us, where we've actually integrated with the call centers, and we've focused on improving the Net Promoter Scores.
Thank you. So yeah, we're going to start off with some results, go back to front. For anyone that's not aware, Net Promoter Score is after a customer has talked with your call center or had any kind of dialogue with you as a company. They usually get sent a survey asking if you would recommend them to their friends and family. So through the work we're about to say, we managed to improve our Net Promoter Score by 26%. We managed to increase the handled conversations by our call center agents by 3%, which is small but marginal gain. And our customer satisfaction with the overall quality of our product actually also raised by 3%. So the way we did this, our initial approach, again, goes back to the Toyota way, and we had a go and see day. So we went to our call center, we sat down with the call center agents for a day, rotated through the different areas, and just saw what it was like for them to have to manage in that space. One of the things that we'd never really anticipated was, with the merger, this is now 2 companies, 2 separate operating systems being managed by one call center team. So each of those agents is sitting there with their computer, overdone it on the example here, but they've got their 2 screens with each operating system on. But within each operating system, they've got 8 to 10 individual screens that they actually need to go to get the information that that customer is waiting to hear about. So in reality, this image is what they need to be able to see. Both of those operating systems, fairly slow, fairly unintuitive, and it results in the call center agent having to sit there and just stay silent or make small talk with the customer while they wait for the information to come up. So we went off and we spoke to some software engineers and we spoke to our data scientists, and we ended up building out a very simple one-page interface that the call center agents could have that has the basic information that the customer is needed, either to validate their identity or to talk about the issues they're having. And then it gets combined with data science recommendations and churn likelihood in order to help the call center agent with the conversations that they need to have. So what did this do for us? This means that the customer doesn't have to be on the phone for ages. And no one wants to be on the phone call to companies these days. So it's an improvement to the customer experience. Being able to provide the recommendations of what to offer to the customer, and that's backed by data, improves the customer retention and upsell experience. And then for the company as a whole, we managed to increase the efficiency of the call center, so that's saving costs for the business.
So how did our philosophy help? Well, one of the things we'd done is, before we went on this journey, every quarter I play a game with the team. And it's called Dragon's Den. Now, that will probably mean nothing to the Americans, but Shark Tank is the equivalent program in America. Now, Ollie does not have £1 million to give away to everyone who comes up with a great idea. But what we do have is we have time and we have resource. So every quarter, every member of the team has to pitch an idea, tell us how long it will take to develop, and how much resource they want from the team. We will choose the best ones of those and give them the resource and the time within that quarter to develop that product. The great thing about this is that most of the team were already thinking about how we go to lower latency data. And when I'm talking about low latency data, it's not just events, movements, and pups-ups and bringing stuff through. We're talking about transforming data at speed. And those guys had actually already built these products. Ollie can talk more about the products now.
So the important thing with a lot of these innovation projects is not that it's successful, but it's that we learn from it. And this main thing that we're looking at now is actually one that we initially looked at as a way of reducing waste in our processing, and our near real-time output came by as a byproduct. So when we talk about waste reduction, again, we're looking back at the Toyota way here. There's 7 types of waste reduction. We're not going to go through all of those now. There's only 2 which are relevant to what we're looking at. So one of those is over-processing. We want to reduce the amount of data we push through the system to just what we need. And then the other one is waiting. So we want to reduce the amount of time where we could be processing data, but we're not. So anyone here that's on Google BigQuery should hopefully recognize this graph in red. It's our slot usage. And what we're looking at here is our daily run, our standard processing of data. And that takes place in the morning. It takes about 5 hours. And so I spoke to Gordon. I was like, how do we improve this? How do we reduce the waste in this process? And then Gordon hit me with another anecdote.
So I turned around to Ollie and I said, Ollie, have you ever heard the story of Steve Jobs? So Steve Jobs walks into his room and his chief engineer is sitting there. And Steve Jobs is not happy because the engineer is trying to explain to Steve that he can't fit any more hardware in the phone. It's full. And so Steve Jobs looks at him and he says, I don't believe you. And they have this discussion and Steve Jobs is not having it. And he picks up the phone and he walks over to a fish tank and he drops the prototype phone in the fish tank. And he turns around to the chief engineer and says, what do you see? And the chief engineer looks at it and he says, there's bubbles. And he said, exactly. There's bubbles coming out from the phone. There's space. So I then challenged Ollie.
Yeah, so with that anecdote in mind, we then looked at our model timing of this run within DBT. And sure enough, we see a lot of gaps in there, a lot of gaps between our processing. That's the bubbles we want to be able to eliminate. So effectively, what we want to get to with this slightly different view of the graph, rather than having these large peaks and then troughs of no processing, can we get it to a state of constant low-level slot usage throughout the day? To do this, realistically, we need to look at a full incremental system. So in order to do this, we're going to have to use the push system, and we see a lot of issues with the standard way of processing data through the push system. So if we want to get this process going as efficiently as possible, we only want to be processing the records since the last run. We don't want to have any kind of extra data that isn't needed in there. We only want to store the data that is currently being processed. Again, we don't want to be appending data on top of staging tables. We just want the exact data that is needed. And then, as we've said, we want to reduce the gap between runs to as small as possible. So we've got our example diagram here, and this is an hourly run we're looking at. If we've got being kicked off every hour and the process takes 50 minutes, we're looking at 10 minutes of wasted processing time there. And then if we manage to speed that run up, we're not going to have the benefits that we should be getting because you've still got to wait until the next hour for that to kick off. We also run the risk of needing to put through code changes to fix any issues. So if we have a breakage in our run, then that goes over the next one. If you're trying to do it as efficiently as possible and you're only processing the data that's required, you're running the risk of losing that data and having to go put code changes in to get it back. So what is the solution that we saw to this? We see this, again, looking back at the Toyota way, we need to use a pull system. So rather than having that push system kicking data off every hour, every 10 minutes, every 5 minutes, within the pull system, we kick the data off, and as it flows through the system, it gets to a certain checkpoint, and that checkpoint is the successful trigger for the data to start again. So we end up with a continuous flow of data. The benefit this gives us is that if there is a breakage in our run, if something has gone wrong, we don't have to do anything. The run is going to stop itself because that successful trigger won't be sent. So now we get on to the technical bit, and I'll pass over to Arun.
Thanks, Ollie. So now we have covered the bigger picture of our project. I would like to dive into some of the technical bits. I'm not going to show heaps of code and bore you all. I'm just going to cover certain key principles which we have implemented using dbt Cloud. So the first thing is we have utilized the circular referencing of our model using this ginger command to self-reference our model to get the latest updated timestamp of the processed data. So this helps us in going back to the principles like reducing the waste, and also like we are not over processing already processed data. And to also like adequately like to update our final models, we use the DBT's insert override strategy. And from the Dragon's Den idea, like my colleagues spoke before, we implemented the delta tracking principle, which Ali is going to give an overview about.
Yeah, so just a very brief one, because this is a separate innovation project that we had. But delta tracking is a way of looking at the data going through the system, isolating the pieces that are actually going to make a material effect to the data product you're using, and then make sure we're only tracking the changes against those rather than everything that could be coming through that source. So we can use that to reduce the waste in our system and get that process going faster.
Yeah, this helps us seamlessly flowing the data from end to end. And we have like moved from the idea to implementing it in production, like within a week's time. So in the next slide, I'm going to show like how we have orchestrated this in the DBT cloud. So it's straightforward. We have used the DBT cloud's functionality of kicking a job after completion of a step. So we have divided our continuous flow model into different steps, and once the final step's completed, we kickstart the first step. So the data model flows continuously. And we are also like working with DBT now to see like how to re-trigger a job automatically without any manual intervention, and also like group different jobs under a single group. Because if you see like we are continuously running these jobs, it's going to fill up the run history. And this is our DBT lineage for one of our low latency project. The key challenge in this project is we need to deal with both batch processing data and also like events data, which we need to provide in just in time. So if you see this red bit, that's the only part which the business wants real-time data, and the other parts are like batch processing data. So here we have implemented the continuous flow only to this flow. So we are not over processing all the like batch process data again and again as part of this continuous flow. And yeah, this one, like we have quantified one of our project, how we have moved from key stages from starting using a full refresh model to our different stages.
Yeah, so here it's quite interesting. Where we started from, so Arun, the first graph that we're looking at here, that is straight out from our batch job. Yeah.
Yeah.
So when we look at our batch job, that is how long it's taking. Yeah, 47 minutes. Fine on a batch job when our run is 5 hours, we've got 8, 12 parallel runs going at the same time, not a problem.
Yeah, so we have implemented the like standard incremental strategy, and obviously it's going to reduce how much we are processing. So it has reduced it to like 130 gigabytes, and then the job time has gone down to like less than 140 seconds. But there's so much improvement because the business wants the jobs, the real-time data to be updated in less than a minute. So that's where delta tracking principle came in. So the final model, like where we are using the insert override strategy, is scanning the whole model. So by implementing the delta tracking changes, we are only looking into the columns which have changed. So right now, like our project, it's running more than 500 times a day, and the runtime is like reduced to less than 1 minute.
So the key thing here is it's incremental steps as we move to that model. Don't try and run straight to that model. But the impact is massive. You're going from 47 minutes down to 50 seconds. The stakeholders' requirement was within a minute. So we hit that. Now, the important thing to remember without making any promises, it's a pull system. So sometimes it's going to go above a minute. Sometimes it's going to go below. It all depends on how much data is coming through the system at any one time. Yeah, so if we're hitting 2 o'clock, there aren't too many people buying mobile phones. There are some, but not too many people buying mobile phones at 2 o'clock. That will come down. That will be even below that 50 seconds. But there are caveats. We can't replace pups-ups and things like that. Just to kick off, DBT's got a 3-minute lag, a 3-second, not 3 minute, 3-second lag before it kicks anything off anyway. So it's not perfect for that. But in high transformation projects with Windows functions running and stuff like that, this is an ideal way of working. So in summary, where do we get to? So we took that risk to rebuild the whole data infrastructure. We've got a stabilized product because of that. We actually built, we had the advantage. We had a greenfield site. We knew where we wanted to get to. We wanted to support AI. We wanted to support ML, large language models, all that stuff. That's what we wanted to supply. Their demand was lower latency. But we didn't try and build low latency from the start. We went for the traditional build and make it stable, standardize our processes, get the most innovative team together, and then build in the quality. Once we had those 4 things, that was the time that we can now focus on doing what we call just-in-time. And we have now got the ability to build specific products within our runs or transform models to actually start. So we can integrate into models if there's certain parts of the model that they want, that the consumer wants to have a lower latency than the rest of the model, we can start doing that. It's always tricky because you've got more up-to-date data than other data, but we can do that now. And that basically leads to customers first, which means as a side product of that, we have low cost, quality, and short lead times. And when I talk about short lead times, it's lead times to market. We can implement changes in our system really quickly. We can deploy stuff to prod within 24 hours, within 48 hours. That's the speed that we need to work out to win this battle of all the mobile phone companies in the UK moving to a customer first. We need to be moving faster than all our competitors. And that's what we've aimed to do, and that's what we developed today. And hopefully in the future, we'll be able to do a presentation one day where we've got a flattened level production system that we can show you how to go from the batch to that consistent low level of data, transformed data coming through our system. The other thing that we haven't really touched on today, and I don't know how much time we've got, plenty of time, is that in Europe, we have something called GDPR. And so GDPR is the right for the customer to be forgotten, to have all his data removed, for us not to process his data. There's eight things. I won't bore you because they bore me all the time. And literally, we have to run an idempotent system. So in a traditional world where people talk about type 2, something I came across for the first time in my life when I joined this company, where you're incrementally just putting data on top of each other and then updating the data or rerunning the data set to add a column, we'd never do that stuff. All our data is all our infrastructure is code-based. If all our data got deleted today, it would literally take us 8 hours to recover our whole infrastructure if the source data is there. We just push one button, push play, and the whole thing comes back. That is so important, and that is where we started, is that was the agreement we all made with each other, is that is the most important principle, and that allows us to then do these things like continuous flow in our model. Cool. Right, we've got 1 minute, 40 seconds, but if there's any questions, we're happy to all come and see us afterwards.
Yep. Thank you, everybody.
Thank you.
Thank you.